All right, so if you take an equation that has fractions in it, uh, what you want it to do is look to get rid of your fractions completely. And you can do this by multiplying by the least common denominator of all the fractions involved in the entire equation. So when you look at this, we're going to multiply this entire quantity by the LCD of all the fractions involved. Well, we need a factor of 3, we need a factor of 4, and we need a factor of 1. So what's the smallest number that has factors of 3, 4, and 1? 12. So we're going to multiply that by each of these, or multiply that LCD to each of these individual fractions on both sides of the equation. It remains balanced in that way. And when you do, if you think about what we do, it's the exact same concept for when we combine fractions. If we take our first fraction's numerator x, we multiply it by the LCD factor that was missing from this LCD. So 3 goes into 12, leaving a 4, plus the next fraction's numerator 3x times what's left from 12 when you cancel out the 4. 3, and then finally 2 times 12. Nothing gets canceled, so it's the whole LCD factor. And then it just becomes a solving problem. So you isolate the variable, just like we did in any linear equation, giving us 4x plus 9x is equal to 24. 13x is 24. We're looking to completely isolate this variable, so we undo all the operations, and you get your solution 24 over 13. Now, it's a good idea to check your solution again, in this case, if you have enough time to go back and do that. With fractions, you're probably less likely to test it, but it's still a good idea to do it.